Hello everyone. Let us look these questions. We are having two questions in this. We will solve both of those. First one, evaluate integration of e to the power of ax sin bx dx, followed by the next one also. So let us solve the first one and second one both. Let us start with I equal to integration of e to the power of ax sin bx dx. Okay. We know the condition of integration of two functions f of x into g of x dx. That is f of x integration of g of x dx minus integration of derivative of f of x into integration of g of x dx whole dx. Right now, in this case, our first function will be sin bx and our second function is e to the power of ax. So when you apply the formula for the above one, so it becomes sin bx integration of e to the power of ax dx minus integration of derivative of sin bx into integration of e to the power of ax dx whole dx. So this will be sin bx into e to the power of ax by a internal derivative minus integration of this part will be cos bx into internal derivative will be b into this part becomes e to the power of ax by a dx. So next step, e to the power of ax by a sin bx minus b by a comes outside. You are left with e to the power of ax into cos bx dx. Again, we'll apply the same condition, just how we are done with this. We'll apply for this one also. So our next step will be is I equal to, we came up to here, that is e to the power of ax by a sin bx minus b by a. Now we'll apply the condition here. Again, cos bx becomes the first function, e to the power of ax becomes the second function. So this will be cos bx into integration of e to the power of ax dx minus integration of derivative of cos bx into integration of e to the power of ax dx whole dx. This is what you are left with. So this part will be e to the power of ax by a sin bx. So I have I here minus b by a cos bx into e to the power of ax by a minus integration of this part will be cos bx derivative is minus sin bx into b into again this integration it will be e to the power of ax by a dx. Right. So next step, I equal to e to the power of ax by a sin bx minus b by a into e to the power of ax by a cos bx minus again this minus into this minus becomes plus. This is plus and b by a comes outside here. B by a to integration of e to the power of ax sin bx. Right? This is we have here. We know that this is what we estimated it as. We took it as I. Right? E to the power of ax sin bx we took it as I. That is integration part. So now in the place of this integration of e to the power of ax sin bx dx, I will write here as I. See, we already took in this. Okay. So exactly in the place of integration of e to the power of ax sin bx dx, I will write as I. Then what does it become? I equal to e to the power of ax by a sin bx minus, simplify with respect to the brackets, open the brackets here. This becomes b by a square e to the power of ax cos bx minus b square by a square. Okay, one more step we'll write here. Integration of e to the power of ax sin bx dx. As I discussed earlier, In the place of this, I will write it as I. So this becomes integration I equal to e to the power of ax by a sin bx minus b by a square e to the power of ax cos bx minus b square by a square I. Now minus b square by a square I take to the LHS part. So this becomes I plus b square by a square I equal to, I am left with e to the power of ax by a sin bx minus b by a square e to the power of ax cos bx. Here I will take the LCM of a square. So I am left with a square I plus b square I is equal to, here also I will take the LCM of a square. So I have only one a here. So I will write it as a into e to the power of ax sin bx minus b e to the power of ax cos bx. A square gets cancelled. From here I will get as I equal to 1 by a square plus b square. I am taking this common. So I will be left with e to the power of ax sin bx minus, of course we have a here, and b e to the power of ax cos bx. When I take here a square plus b, I will take I common and I will send there. So this will come to the denominator. So next step will be a final answer, that is I equal to, I will take out even e to the power of ax common. So this becomes e to the power of ax by a square plus b square into a sin bx minus b cos bx. Therefore, finally, integration of e to the power of ax sin bx dx. This part will be e to the power of ax by a square plus b square. Of course, here we are having plus c also, right? Here also it has, it starts from here, plus c plus c. Okay. So this part will be e to the power of ax by a square plus b square into a sin bx minus b cos bx plus c. So we proved already. So we proved it for integration of e to the power of ax sin bx dx. Now we will go for the next one, that is integration of e to the power of ax cos bx dx. Okay. Now again the same thing for integration of e to the power of ax cos bx dx. So let I is equal to integration of e to the power of ax cos bx dx. Again the same condition, that is integration of, here we are having two functions, integration of f of x into g of x dx, that is f of x into integration of g of x dx minus integration of derivative of first function, that is f of x, into integration of g of x dx whole dx. Right? Here also same thing, cos bx becomes the first function and e to the power of ax becomes the second function. So again, so when you go for this, it will be cos bx into integration of e to the power of ax dx minus integration of derivative of cos bx into integration of e to the power of ax dx whole dx. So this becomes cos bx into e to the power of ax by a minus integration of derivative of cos bx minus sin bx into b into, this will be e to the power of ax by a dx. So this becomes e to the power of ax by a cos bx, and this minus and b by a comes outside, this minus and this minus becomes plus, plus b by a integration of e to the power of ax sin bx dx. Right? So again the same thing, I'll simplify this one as this part what we have done here. Again sin bx becomes the first function and e to the power of ax becomes the second function. Again the same way. So now the next step will be I equal to what we got here, that is e to the power of ax by a cos bx, right, plus b by a into, here this part will be sin bx into integration of e to the power of ax dx minus integration of derivative of first function, that is sin bx, into integration of second function, that is e to the power of ax dx whole dx, right. So this part will be I equal to e to the power of ax by a cos bx plus b by a to sin bx into e to the power of ax by a, right, minus integration of, when you do the derivative of this will be cos bx into b, okay, into, again this part becomes, when you do the integration of this will be e to the power of ax by a dx. So now the next part, it is e to the power of ax by a cos bx plus b by a e to the power of ax by a sin bx, okay, minus this b by a comes outside, b by a, I am left with integration of e to the power of ax cos bx dx. We know that integration of e to the power of ax cos bx dx, we estimate it as I. So in the place of this, I can substitute as I here. Okay, so I equal to e to the power of ax by a cos bx plus b by a square e to the power of ax sin bx minus b square by a square I. Okay, again I'll bring this b square by a square, that is minus b square by a square I to the LHS. So this becomes I plus b square by a square I is equal to, here also if I take a square as the LCM in the remaining two terms, I will get it as a into e to the power of ax cos bx plus b into e to the power of ax sin bx, right. Next step, when I take LCM of a square, this becomes a square I plus b square I equal to, here I can take out e to the power of ax common. So if I take out e to the power of ax common, I will be left with a cos bx plus b sin bx, b sin bx by a square. Of course, here also you are left with plus c plus c. Okay, here you have plus c. So a square gets cancelled. Here if I take I common, it will be I into a square plus b square is equal to e to the power of ax into a cos bx plus b sin bx plus c. So from this, I equal to, when I send this a square plus b square to that side, it comes to the denominator. So this becomes e to the power of ax by a square plus b square into a cos bx plus b sin bx plus c, right. So finally, therefore, integration of e to the power of ax cos bx dx, you got this as e to the power of ax by a square plus b square a cos bx plus b sin bx plus c, right. So finally, we got the for both the questions. I hope you got the solutions here. We'll meet with the next question next time. Thank you.